Assalamualaikum guys, welcome to another video of Haya skills, and today we are going to do exercise 9.2, which is about sequences, just like we did exercise 9.1, which was about sequences. But here in 9.2 we are going to learn about a formula to find the next term of a sequence. It is term n equals to term 1 plus n minus 1 into d. Now what's this term n, term 1, n and d? Okay, so first of all, this term n means the term you are finding. This a denotes the term and this n shows which term. For example, you are finding the 15th term, the 16th term, the second term, so you will write here 2, 15, 16, like that. Now a1, now as I said, this n shows the term, and now here there is written 1. Now this 1 means the first term, right? Plus n, now here n is the term. As you are finding the 15th term, so you will write here 15. You are finding the 6th term, so you will write here 6, like that. Minus 1, it's simple, into d. Now this d is the common difference. The common difference we were finding in 9.1, as we learned that the common difference here was 2 plus 2 plus 2. So here you will use the word common difference. So let's move towards the exercise. Question 1 is find the 15 and the nth term for each of the following sequences. Now this nth term means any term. We don't know which term they are talking about, so we will simply write here n and then we will use the formula. For example, if we see part 1, it is 5, 7, 9, 11, 13. So here what's the common difference? The common difference is plus 2. 2 is being added to each number to form the next term. So let's use the formula and find the 15th term of the sequence. Okay, so an, we will write a 15th equals to a1. a1 is 5 plus n minus 1. n is right now 15 minus 1 into common difference is 2 or plus 2. If you write plus 2, you must write it in bracket because 2 is not being added to it but being multiplied to it. As we saw in the formula, d is being multiplied to n minus 1. Okay, so 5 plus 15 minus 1 is 14 into 2. 14 into 2 is 28. So 5 plus 28 and 5 plus 28 is 33. So our answer is 33. Means the 15th term of the sequence will be 33. Same case, now we are going to find the nth term of the sequence. So 5 first term plus n minus 1. We'll write here n this time because we used n over here. n minus 1 into, what's the common difference? 2. Now we cannot subtract it first of all, so we will first multiply this 2 because we know n is a variable and we don't know the number of n, so we will multiply this 2 first. So 5 plus 2n minus 2. Why 2 n's are 2n and 2 1's are 2? So 5 minus 2 will be 3 plus 2n. So our simplified formula for an here in this part will be an is equal to 3 plus 2n. So for part A, only for this part A, you can also use this formula to find the 15th term. How? If you wrote here 15, 2 into 15, 30, and 30 plus 3, 33, you got the same answer. So this is the simplified formula as I said. Now in part B, again there is an addition. In part C, 3 3s are 9, 9 3s are 27, 27 3s are 81, 81 3s are 243. Now the common difference is not multiplied by 3 because common difference is either the subtraction of a number or the addition of a number. Then you can see that that is a common difference. But if something is being multiplied, something is being squared, something is being divided by 2 or again and again divided by itself, then that won't be the common difference. So for that questions, you will need to find a formula yourself. You'll have to make a formula using the word n, and n will be the position of the term, and then you will find a formula. So let's try to make a formula for part C. Okay, so first of all, you must know that what's happening in each term. So if we take the example of second term, the number 9, so here 3 is being multiplied 2 times and it is the second term. In number 3 term, the 3 is being multiplied 3 times. In fourth term, the 3 is being multiplied 4 times. So accordingly, our formula can be 3n for part C, right? For part C, our formula can be 3n. Why 3n? Because if you use this formula, for example, for number 4, for the fourth term, you may have to find the fourth term. So how? 3 power of 4. Now this 3 power 4 means 3 into 3 into 3 into 3, and this is 3 3s are 9, 9 3s are 27, 27 3s are 81. So your answer will be 81. So 3n is the perfect formula. Now they said you also have to find the 15th term, so write 315, which is equal to, multiply this 315 times and then you will get a large number. So that will be your answer. So part D contains a common difference. Part E is 8, 5, 2. Again, you will use this formula. You will write here -3 because the common difference is -3 here. Part F, we have the common difference -2. In part G, we have the common difference -1.2. And in part H, we don't have a common difference. Look, 2, 8, 18, 32, 50. We don't have any sort of common difference. So there must be any other sort of rule in it. Try to figure out what is the rule in it. Term 1 is being multiplied to 2, we can say, okay, so 2 under 2, we can say. But if we use this formula for the second term is 2, right? 2 means the second term. I'm considering this all as n. So 2 into 2, if we again multiply 2, we'll get 4. But wait, if you do its square, right? If you add a square on it, 1 ones are 1 and 1 into 2, 2. They are correct. 2 twos are 4, 4 into 2, 8. We'll get 8, which is the correct answer. Let's try it for 18. If it works, then means our imagination is correct. 3 squared 2, 3 3s are 9, 9 2s are 18. So I was correct. Means the formula here is this. Now what was this 1, 2, 3? The thing which was changing, that will be the n, that will be the variable, because variable varies. So our formula will be 2n square. So to find the 15th term, we will write 15 and on the place of n, and we will do 15 square, and then we will multiply that with 2. And so 15 into 15 is 225. 225 into 2, which will then give you 450. So your answer will be 450 for the 15th term. Okay, E15, 450. So in this way, you are going to do question 1. Question 1 was quite simple. So in question 1, you had to make the formula either yourself or you had to use this formula. But remember, you can use the formula only and only when you have the common difference. Okay, so question 2 is consider the sequence, which is 4, 12, 20, 28, 36, 44, 52. Seems like it has a common difference, and that is 8 plus 8. Because if you plus 8 to 4, you get 12. 12 plus 8, 20. 20 plus 8, 28. Find the nth term of the sequence. Simple, using this formula, find the nth term. Then find the 500th term of the sequence simply by using this formula. Instead of n, use 500 and then you will get the formula. And common difference will be plus 8 or just 8. Okay, which term of the sequence has the value 236? Show full working. Okay, so we need to know that term right now. Which term has this value? So here in this part C, we are going to find n. an equals to a1 plus n minus 1 into d. Okay, so what's an? An is 236 right now. How? Because they said that the term is 236. We know what's the term. The term is 236. But which number term is it? Which nth is it? We need to find that. A1 is 4 plus n is what we do not know, and we are going to find that, and d is the common difference, which is 8 right now. So just like a linear equation question, we are going to solve it. You can check the linear equation in my end screen. Okay, so 4 plus 8 into n will be 8n. Minus 8 ones are 8. 4 minus 8 will be minus 4, right? Minus 4 plus 8n into 236. Now we need to move this minus 4, so 236 plus 4 equals to 8n. 236 plus 4 will be 240 equals to 8n. Divide this 8 on both sides to remove this 8 from the m. 8 1 8, 8 0 0, 8 0 0, so 30 equals to n. Okay, so it means 236 is the 30th term of the sequence. Here A30 equals to 236. Part D is show that 154 is not a term of the sequence. But we have to prove how we can say that it is not a term of the sequence. So we can say that by getting a decimal value of n. If we get a decimal value of n, means that is not a term of the sequence. How? Because we write all the terms in natural numbers. We say first term is this, second term is this, third term is this. We do not say 1.5th term is this, 3.7th term is this, right? So means if we say 1.5th term is this, means that term, the 1.5th term is not the term of that sequence. So here if we get the value of n, a decimal number, means 154 won't be the term of the sequence. Okay, so let's see. We are going to do the same thing, but here we are going to write 154 equals to 4 plus n minus 1 into 8. Okay, so 4 plus 8, 8n minus 8. Okay, 4 minus 8 minus 4 plus 8n, and so to remove this minus 4, we will add this 4 to 154. Now we will get 158 equals to 8n. Now we will divide 158 over 8. So 158 divided by 8, which is 19.75. So this means that 154 is not a term of the sequence, because 155 is the 19.75th term of the sequence, which is incorrect. it's not incorrect that it's the 19.75 term of the sequence. It's correct, but we do not write terms in decimal form, that this term is the decimal form of the number. Okay, so question 3 is, not all sequences progress in the same way. You need to use your imagination to find the end term for each of these. Okay, so for here, we are not going to use this formula. Instead, we are going to use our imagination to find the end term. Means we are going to make another formula, a new formula, just like we did in question 1 for some of them. Let's figure out the sequence. Is 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32. Each of the denominators seems to be the multiples of 2, right? 2 1s are 2, 2 2s are 4, 2 2s are 4, 4 2s are 8, 2 2s are 4, 4 2s are 8, 8 2s are 16. So here 2 is being multiplied to itself as many times as it's the term of the sequence. For example, the first term is 2. 2 is not multiplied to itself, right? In second, 2 is being multiplied to itself 2 times. Why? Because this is the second term. In the third term, 2 is being multiplied to itself 3 times because it is the third term. In the fourth, 2 is being multiplied to itself 4 times. 2 2s are 4, 4 2s are 8, 8 2s are 16. And in the fifth, 2 is being multiplied to itself 5 times. So in this way, we can make the sequence. Just like we made the sequence for that 3 power n, it's the same. But here it will be 1 by 2 power n. 1 is same for all. So using the formula, we can simply determine it. So if we are finding the fourth term, so what will be 2 power 4? And 2 power 4 means 2 into 2 into 2 into 2. So 2 to the 4, 4 to the 8, 8 to the 16, 1 by 16. And the fourth term is 1 by 16. So part B is 3 by 8, 7 by 11, 11 by 14 and 5 by 15 by 17. So now in this part you can see that 4 is being added to the numerators, however 3 is being added to the denominators, as 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 4 is 15, 8 plus 3 is 11, 11 plus 3 is 14, 14 plus 3 is 17, right? Let's do it 4, 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4 is a 16. The thing is we need to subtract 1 from it, right? For if we make the formula like this, 4 and minus 1 for the numerator, okay? So 4 2s are 8, 4 2s are 8, minus 1 7. 4 3s are 12, 12 minus 1 11, 4 4 is 16, 16 minus 1 15 is correct. So if we do the same case with the 3 1, 3 and minus 1, because 3 was being added to it and in the numerators 4 was being added to it. So 3 and minus 1, 3 2s are 6. Wait, yeah, it's correct. 2s are 6. Minus 1 is 5. Actually we are doing wrong, I guess. 3 3s are 9, 9 minus 1 is something else. Instead of subtracting 1, if we add something, wait, 3 2s are 6, 7, 8, 9, 10, 11, 5. We have to add 5 to it. But if we add 5 to it, so 3 2s are 6, 6 plus 5, 11. We are correct here. 3 3s are 9, 9 plus 5, 14. We are correct here too. So we are correct. Part C is 9 by 64. Wait, they both seem kinda relatable. Look, 9 by 64 and 3 by 3 3s are 9, 8 8s are 64, 49 by 121, 7 7s are 49, 11 11s are 121, 121 by 196, 11 11s are 121, 14 14s are 196. Squaring the same numbers here. So what if we squared this formula? We squared this formula for both. So in this way, this will be our formula. So part D is minus 2 by 3, minus 1 by 6, 1 by 3, 5 by 6 and 4 by 3. First we must try to figure out the common difference for the imagination formula. Okay, so to find the common difference, we will subtract this first term from the second term. So minus 1 by 6 minus 2 by 3. So minus 1 is plus. Minus 1 by 6 plus 2 by 3. The LCM of 6, 3 and 6. So 6, 1 to 6, 1 into 1 minus 1. 3, 2 is a 6. 2 into 2, 4 plus 4. So 4 minus 1 is what? 4 minus 1 is 3 by 6. Or if we simplify it, we can say 1 by 2. So 1 by 2. We found that the common difference for part D was 1 by 2, right? So what if we use this previous formula? N term equals to first term plus n minus 1 into D. We can use this formula here. Why? Because we do have the common difference. The main thing we need is the common difference, and we know that the first term in the sequence was minus 2 by 3. Minus 2 by 3 plus the n term is what we do not know, which we are going to make the formula with, and the common difference is 1 by 2. Now we are going to multiply this 1 by 2 with this n and with this 1. So minus 2 by 3 plus 1 by 2n and minus plus minus, 1 1 is 1 by 2. We are going to combine the like terms. Minus 2 by 3 minus 1 by 2 plus 1 n by 2, or you can just say n by 2 because 1 is not mandatory, right? As I explained in my algebraic expressions videos. LCM of 3 and 2 is 6, so 3 2 is 6, 2 2s are 4, minus 4, and 2 3s are 6, 3 1s are 3, minus 3. So minus 4 minus 3 n by 2. Minus minus plus 4 plus 3 7 minus 7 by 6 plus n by 2. So this is our formula for part D. So thanks for watching. This was exercise 9.2 part 1. We'll meet in the next video in exercise 9.2 part 2. Till then, Allah Hafiz, and don't forget to like and subscribe.